Hi you guys, we're doing 8.3 dot products and vector projections, and really we're just going to do the first part of 8.3, so we won't even get into vector projections. So our objective for this will be to find the dot product of two vectors and use the dot product to find the angle between them. So our vocab is dot product and orthogonal. The dot product of two vectors, A and B, is just going to be I have an eraser on. Your first one times your first one and the second one. So I'm just going to actually call this X and Y for right now. So you're going to multiply your X's and then add it to your Y's multiplied. That's really it for the dot product. And it's called a dot product, I believe, because it's written like this with a dot in the middle. And then orthogonal vectors, if you have a dot product of A and B and it equals 0, then the vectors are orthogonal. So they are only orthogonal if, when multiplied, they equal 0. So let's try a couple of these. It says find the dot product of vector u and vector v if u is negative 3, 4, and v is 3, 6, and then determine if they're orthogonal. Okay. So I'm going to take vector u, dot product, vector v, and I'm going to take negative 3 times 3, so I get negative 9. I'm going to add it to 4 times 6, and I get 24, which is 15. Because this is not 0, then it is not orthogonal. We'll try the next one. It says u and v are 2, 7 and negative 14, 4. So again, the dot product, we're just going to multiply the x's in a sense. So 2 times negative 14 is negative 28, and add it to 7 times 4, which is 28. Look at that, we get a 0 for the product, which means this is definitely orthogonal. And that's all orthogonal means. If you look at these properties of dot products, they're pretty much like you'd expect. There's a commutative property, distributive property, scalar multiplication property, and a zero vector dot product property. Those are things that make common sense, right? So now we're going to look at the dot product and vector magnitude relationship. So if you have a vector, u, if you dot product it to itself, that's the same thing as the magnitude of it squared. So if I found the dot product of a vector upon itself and then took the square root of it, I would have the magnitude. That's what we'll do for the next couple examples. So I'm going to take this vector A and dot product it. So I'm just going to actually write it out so we can see it. I should put a dot here and not here. Okay, so it's the same vector and we're using dot product. So negative 6 times negative 6 is 36, plus 5 times 5 is 25. And then to find the magnitude of that, we will just need to take the square root. And that's what, 61. So the magnitude of vector A is the square root of 61. And I guess if you find a decimal approximation, it's about 7.81. Let's try it again. It's not hard, but it can be a little confusing. So we will take vector v dot product itself. So it's negative 4 times negative 4, which is 16, plus negative 1 times negative 1, which is 1. So we have 17, and to find the magnitude, we just need to take the square root of it. So vector v has a magnitude of the square root of 17. think the last thing we're going to talk about is angles between two vectors, or an angle between two vectors. And this has kind of a confusing formula as well, where it's not difficult to do, but it's easy to forget how to do it, I guess. So what you do is if you have two vectors and you want to know the angle between them, there's this formula. And this is saying that the cosine of theta is going to be the dot product of the two vectors over the magnitude of vector A times the magnitude of vector B. Let's try this out. So I'm going to say cosine of theta is going to be equal to, and I need to have the dot product, so I'll write this out, u times v, u dot product v, over the magnitude of u times the magnitude of v. So that is going to be, so I'll find the dot product of these two. So negative 3 times 2 is negative 6, plus negative 5 times negative 3, so plus 15. So the numerator on that is 9. And then to find the magnitude, we'll use what we just learned, and we're really just finding the dot product of itself and then taking the square root of it. So u dot product u is going to be 9, because negative 3 times negative 3, plus 25. So 34, so it's going to be the square root of 34 for the magnitude. So I'm going to write that down here. And then the same thing with v. If we find the dot product of vector v, we have 4 plus 9, or 13. So vector v is the square root of 13. So I'll put that down here. Let's see, I think I had this simplified on my notes somewhere. This was like 442. But if you throw this in your calculator, you're going to get a decimal. I had it somewhere. I get like 0.428, whatever. So remember, you need to use the inverse cosine. So inverse cosine of that number, that 0.428, that's going to give you your theta, which I get 64.7 degrees, approximately. Okay, we'll do another one. So this one we need to find the angle between vector u at 1, negative 4 and vector v at 2, 6. We will use our formula where cosine of theta is equal to the dot product of u and v. So I'm just going to go ahead and do the dot product of u and v. So I have 1 times 2, which is 2, plus negative 4 times 6, so negative 24. So my numerator looks like it's going to be 22. And then I need the magnitude of u and the magnitude of, oh, did I say 22? I meant negative 22. Magnitude of u and the magnitude of v. So I will find the dot product of u on itself, which is going to be 1 plus 16, or 17, and we just need the square root of that. And this will be 4 plus 36, or the square root of 40. And then we're going to go ahead and simplify a little bit. I'm going to throw that into my calculator. Remember, I will need to use cosine, or inverse cosine. So really, I can write inverse cosine of that negative 22 divided by square root of 680. And that will give me my theta in degrees. Okay, I just did it to check it, but yep, it is 147 degrees. 147.5 is probably better. Oh, of course it has to do this. Okay, so 147.5 degrees. I believe that's all I have on here for today. This is what you have for this week. I think it's 2 through 20 for the assignment evens. And I really don't have any suggestions other than just keeping it straight and maybe copying down these problems so you have them. Next week we will do 8.4, and then the week after that we will have a quiz over what we've covered in chapter 8, and that's it. That will be the end of your math career at Lemoore High School. So, not to make anyone cry. Have a good day.